and it looks like we're getting set up. So take it away, Noah, whenever you're ready.
All right, thanks, Amanda. So the previous talks in the course of this day have done an exceptional job of introducing some of the topics that I'd like to address. I have three main takeaways that I'd like to have you all leave with today, and how we replan, how we not only use the plan that is developed prior to the mission, but how that plan is revised as discoveries are made, as things eat into crew time, but also as we on the ground learn things and have to communicate that to the crew. So I'm going to use three examples from Apollo 17 that I hope illustrate things that we can improve on for Artemis. Next slide, please. So I wanted to emphasize a point here that Ben made in his presentation earlier today, and then the bold text is really that. Bill Muehlberger was the PI, the field geology PI, but Jack really was. We all recognize that, and Bill acknowledges that there. He was running the mission from the moon. Bill Muehlberger addresses he was the official one, but what can I do? I can't see stuff like he can, besides he knows better in the first place. And so I think that lesson there alone of allowing the field PI, I'll refer to the field PI in this talk, is really important, that the crew members are empowered to serve as the PI of the field geology investigation. And it's our role in the science support room to facilitate their discoveries and essentially let them do the work and help them where need be. I'm going to talk a lot about EVA-2 on Apollo 17. It was the stressing case. It was the furthest crew went from the LEM in Apollo. It was one of the most challenging explorations we undertook on the surface of the moon, and serves as a great example of what we can do when we're prepared. Next slide, please. We talked a bit about some of the changes that occurred during Apollo 17. This is just a few examples of that. Earlier today, Jim referred to using American football as an analogy to what we'll be doing. Let me use rugby as an example here. I think that might be a little more appropriate. If for anyone's watched rugby, it appears more chaotic, but indeed it's actually organized chaos. And what happens there is you can recognize when something needs to be done. I want the crew member on the surface to be that rugby player, recognizing that a change is coming and we have to respond to that to get to the overall objective of crossing the goal and getting those points. And Jack did that twice on Apollo 17. I'm going to highlight one of those examples here where he called, to use a football analogy, an audible. And we want, again, the crew members to feel that they can do that to achieve the science goal that they have had a hand in drafting. There's a few other changes that occurred at Apollo 17, and we're going to highlight one of those examples in a moment that affected what happened at Station 3. Next slide, please. Again, one of the things that we can best do in preparing for any exploration mission is have a clear set of priorities, goals, and a hierarchy. I have here two examples of priorities of stations listed, basically top priority stations for Apollo 17. Stations 2, 3, and 4 were recognized as the top priority. Again, the meat of EVA-2. And you can see there that the other stations were given lower priorities, different priorities. Another way to think of what happened in 17 that was really so clever is that there were really little families of activities that happened at stations. Station 1, 5, and 10, before it got dropped, were similar, all to investigate subfloor basalts. Stations 2, 3, and 4 were to investigate the light mantle deposits. Stations 6, 7, and 8 to understand the North Massif and the Sculptured Hills. Station 4 and 9 to investigate unique craters on the floor of the Taurus Littrow Valley. And so as we're crafting science objectives, I think it's important for us to group those together, because as we learn something, for instance, okay, we didn't get to go to Station 1 the way we wanted to, but we can do a revised Station 1, but that makes Station 5 that much more important because we know what we're going after at Station 5, is to be able to be flexible in our planning to say, well, which stations are like each other, and maybe if we can't get to one, the second becomes that much more important. So that comes down to the planning and strategy of selecting stations. Second is the objectives of surface experiments. And you'll see in an example where one experiment, particularly the traverse gravimeter, started taking priority over the field geology investigation. And that's something we can't have happen again. And I'll provide some thoughts on that later on. Let's go to the next slide. So let's transform ourselves back to prior to EVA-2. The rover fender has been broken, needs to be replaced. They're going to get a plan to do that. But that time to fix the rover fender has to come from someplace else. And here's how that information is communicated to Jack. And so, Ben, play the clip, please.
And that's about everything we have. As I say in summary, the big changes are going to be extra time at the beginning, taking care of the fender extension, and probably probability of extra time at the end, I will have to see how well the fender works and how things go. The probability of extra time at the end to allow for dusting, and the time spent on those particular activities will probably end up taken out of the task at Station 3 and Station 4. Over. Comments?
Okay, Bob, we copy all that. Obviously, you're going to have to catch us in real time on some of the details there on the charges and the task deletion. One question, did you say we were going to delete the trench at Station 3?
Roger, the trench at the base of the scarp. In other words, some of the stuff that you would be doing while Gene was taking the double core.
What do you gain by that?
Well, no comment on that, Jack.
If you haven't deleted Gene's task, then what am I supposed to do?
You're supposed to help Gene, I guess.
Well, but that's not the way we work it, Bob. Let's play that one in real time.
So what this example shows is really, we can't have that level of miscommunication, lack of clarity between ground and crew. And, there's a number of reasons that happened there, but it was obvious that by deleting only Jack's task, he was left with nothing. You don't save any time. So here's an example of a miscommunication, a missed opportunity. Station 3 worked out well. But as the crew is approaching Station 3, there's a discussion in the back room. We're going to see some more footage here of a discussion of where Station 3 is going to go and what to do there. Oh, and by the way, the field geology team is going to lose more time that they've already had to remove to take care of the fender because we want an additional traverse gravimeter experiment. Ben, let's go to the videotape.
Discovered compared to what we had pre-flight.
Yeah.
Tasks. Well, task and positions. How about? No, the positions are fine. All right, we're still going to Laura. How about? Do you want to change Laura's position at all? The Station 3 crater? No. That has a double purpose.
That ought to be in the transcript that you'll get.
That's the best place to get near the steepest part of the scarp as well as being by the fresh small craters.
Did Jack's remarks on the way out?
He could see it.
He could see it? That didn't change anything, it's just normal.
No, he saw the area that it would be.
Okay, we got the NAN numbers for it.
Yeah.
So let's go to 3, just like we had before.
3 is fine and 4 is fine on where they are.
Great.
And they're both so damn crunched right now.
Okay, it's all set up.
Let us decide which one of the two gets 10 minutes cut out of it.
Some kind of reading.
We can argue by the time we get there.
Okay, it's all set up.
Okay, we got a little bit more time coming out too, where we might have to take an extra traverse gravimeter reading.
Why? That is not a sensible idea.
Well, we're going to take it. I think
What's the rationale? Why should it always come out?
well, it's not always coming out. We just got to make sure we.
In the Sims, we agreed at 50 milligal differences, not the ones that we got going on us now. This doesn't have that value. I don't think it's that important.
Doesn't have anything to do with that.
Oh, no, we already used up the 10 minutes extra, eh?
So what happens here is common on lots of missions. You have differing scientific objectives. It becomes in conflict with each other. That should not happen. The role, as Ben alluded to, as a science lead who integrate those things to make the decision, is this traverse gravimeter experiment worth taking the time from? In some cases not. Bill acknowledges that the ratings that they're seeing don't meet the threshold of taking an extra measurement. That should not happen in Artemis. And ultimately not having an instrument that requires crew intervention would get out of that way. Let's go to the next clip. And lastly, this is, again, Jack calling an audible, again, giving the crew member the opportunity. He knows the science objectives. He knows that those science objectives aren't being met by the samples they have. And so he follows his instincts. And Ben, play the clip.
Okay, and 17, the word from the back room is, with that last rover sample you got, we'd like to go straight to Station 4, and we won't get the one here at 094 and 5.1, excuse me.
Bob, I thought the purpose was to sample the light mantle.
We talked to them about that, but they...
sample light mantle at that last one.
I agree. I talked to them about that, but they are so anxious to get to Station 4, I guess they don't want to do it.
Well, how about it, Gene? A little real time. I think we got you right here. I think we got it. 094 5.1. You got your picture? Okay. That's good enough. Happy? We'll get the sample. Anyway.
And in my
5.1.
Copy that.
few moments before, as I go over here, again, Jack knew the science objectives, what that particular sample was supposed to get, and by removing it,
Copy that.
wouldn't acknowledge, and we go to the next slide, Ben, as I wrap up, they wouldn't accomplish the goals of getting that LRV sample. So he, knowing the samples, knowing the objectives, because he had helped develop them, could make that real-time decision. There are a number of Artemis lessons. Ben addressed many of them. I think one of the most important things that we have to do is not only have the field PI, but again, a clear communication system set up so that changes can be communicated directly from the project scientist, from the science officer to the crew during some of the time that we have, not while they're on EVA, but either in the debrief or pre-brief time. With that, I'll conclude and thank you for your attention.
Thank you so much, Noah. That was really excellent to see.